When the calculation is completed, 2D viewer will be run automatically. There are 7 types of tabs for checking the results. The capacitance tab can only check the result when calculate cap is set to yes in the simulation condition, so I will skip it. At first, let's check the graph. Through this tab, you can check the graph result. Since color filter and domain are not used, only no CF and no domain appears. The next one is display type. There are transmissive, reflective, and transflective types. In this case, please select transmissive. And let's check the BT curve according to the theta change. So, x-axis is voltage and y-axis is transmittance. In the variable list, select theta as variable and then click plot. You can see the graph result. If you click load data, the data is displayed in table form, and by clicking the right mouse button, you can export the data as a CSV file. And there is a graph option that manages the graph. An axis option that sets the left, bottom, right, and top scales of the graph. Trace tool can check the data, mean, and max values at the particular location. Integrate function displays the integral, average, mean, and max values. Please refer to the menu for other functions. The next tab is Structure. You can analyze the 2D structure as well as calculated results, including LC distribution, electric field, and potential distribution. Since color filter and domain are not used, only no CF and no domain appear. The next one is display type. There are transmissive, reflective, and transflective types. In this case, please select transmissive. Also, you can check the transmittance and retardance results. I will click transmittance. So let's check the result. Click plot. You can see that there are 2 types of results. The graph at the top is the transmittance, and at the bottom there is the 2D structure. In the structure, you can turn on and off a layer and also change the layer color. At first, let's check the LC director according to the voltage. Make sure the director is checked. To zoom in the LC area, please press Ctrl key and Z key and then move the mouse wheel. And then let's check the LC behavior by changing the voltages. Also, by clicking the control flood and control line, you can identify the potential distribution. Next, please uncheck the director and check vector. You can identify the distribution of the electric field in the form of a vector. Next is data extraction. Data can be extracted for specific items. It is a 2D structure, so select the direction between vertical or horizontal. Also, there are director, electric field, voltage, and transmittance. And when you want to save a LC profile that can be used in TechWiz DB, check the Generate LC Profile Data file. In this time, I will extract the LC director only. And let's check the LC director according to the particular voltage. For example, I'll only check the 7 volts and then click Extract. The graph file automatically appears. You can check the theta and phi information when the applied voltage is 7 volts. And let's move on to the next tab, 3D graph. You can check the calculated result in the form of 3D graph. If you want to plot the contrast according to theta and phi angles, please set the conditions like this. X-axis is theta, y-axis is phi, and z-axis is contrast. And then click plot. As we want to check the contrast result, select the voltage condition for the white and black states. I will use it as default. Click OK. You can see that there is a 3D graph result. On the right, various conditions for analyzing the data appear. So you can utilize them by yourself. The next tab is polar chart. From subcell to display terms, they are the same as the other tabs. So I will skip them. For the data, let's check the transmittance result. Click plot. The output result is a polar chart representing the transmittance. If you look at the legend displayed on the right, you can see that when the transmittance is low, it is blue. When the transmittance is high, it is red. Let's increase the voltage condition. As the applied voltage increases, it can be seen that the blue part gradually disappears and changes to red. It means that as the voltage increases, the transmittance is higher. For accurate data analysis, legend control is very important. Please click this legend button. I will tell you how to modify the legend setting. At first, please click this Delete All button. Just as an example, let's check the range from 0 to 0.2 at intervals of 0.01. And please click this check button. You can see that the legend is modified. Click OK button. So, by using the legend option, the user can set a specific range to analyze. And on the right, you can identify the mean, max, and average values. Through the view control, set the line options. For example, please check the highlight line and enter the value as 0.2. The dotted line represents the transmittance of 0.2. Click cross-section theta phi. Results can be output in 2D or 3D graph format. If 3D graph is selected, the second axis should be additionally set. In this example, I will use a 2D graph option. And by moving the slide bar, set the viewing angle. I will extract the result when the phi angle is 90 degrees. And just as an example, check all voltages and then click Extract. The extracted graph is shown by user-defined settings. The next one is data extraction specific angle. Extract the data according to user-defined specific angles. Move the theta and click Add. In the same way, move the phi and click Add. And then select x-axis, for example, voltage. For the data set, please select all variables and then click Extract. This is the VT curve by user-defined angles. Additionally, through the data table, you can check the load data. So far, we have covered graph, structure, 3D graph, and polar chart tabs through the simple IPS example. For other tabs, I will explain them through video 7 by adding a color filter.